Good morning, good evening, good afternoon. My name is Kapembwasi Mulinga, and I'm going to be explaining how we perceive sound and how it is related to the stereo image techniques. To start with, to perceive sound, we need our ears and of course the source of that sound. So when the sound reaches our ears, the pinna, the shape of the pinna, they trap that sound and transmit it to the middle ear, and it goes to the inner ear, where it is then converted into electrical signals which are sent to the brain. When we look at stereo image techniques, of course, there are a lot of stereo image techniques, and with me here we have set up a ORTF stereo image technique to explain how we perceive sound. We have chosen this type of technique amongst other stereo image technique like the mid-side. So this gives us a larger image, and since it's um, it's 110 degrees between the microphones. It is close to how we perceive sound, how the distance between the two ears. So this ORTF stereo image techniques, that's why we chose it. And you can hear right now, I'm standing in front of the two microphones, meaning it can be translated as a person standing in front of someone and they speak. So in my right ear is your left ear, and in my left ear is your right ear. So as I'm standing here, the voice is reaching both ends at the same time with the same level of intensity. So as humans, we have binaural cues which we use to determine where the sound is coming from and how far it is. And of course, through memory, we can identify to say this is near us or it's far. So starting with the interaural level difference, which is the difference between the two ears, the amount of amplitude which reaches the two ears. So whilst I'm standing in front of the mic, the distance between the sound source and the two microphones or the two ears is the same. So the level is going to be the same for your left and for your right. And again, if I move to the left here, the level which is going to reach here is smaller than the level which is reaching from here because I'm closer to the left side of the ear or the microphone. So this interaural level difference, it's going to give us to say, if it's louder this side, it shows that the sound is coming from our left side. But if it's louder on the other side, it shows that the sound is coming from this side. And so we can use the interaural level difference to locate sound and of course determine if that sound source is close or far from us. And that is it about interaural level difference. When it comes to the interaural time difference, this is the effect of a sound reaching the two microphones or the two ears at different rates compared at different times compared to each other. So as I'm standing in front here, the sounds are reaching at the same point of the ears. So this is going to tell us, or we are going to perceive to say, the sound is in the center in front of us. And if I move to this side, the sound is going to reach this left ear or left mic faster than the way it is going to, than the time it's going to reach this side. So if I'm here, the sound is going to be localized as coming from your left side because it has reached faster here, and you can hear to say this sound has reached faster on my left side than on my right side, and that is going to give us a clue of where the sound is coming from. So the two binaural cues help us to localize sound So the ILD and the ITD cues gives us the ability to determine the source of sound and of course the distance from the sound source. Having said that, we have a monaural cue which we also use, which is the head-related transfer effect, which comes about with the shape of our ears, the pinna, and of course the whole hearing system. The head-related transfer effect is caused by the head. So if someone is standing in front of you, you're going to recognize that this person is in front of you because of the amount of frequencies which are going to reach the ears. And of course, the sound is going to reach at both ears at the same time. So even the level is going to tell us to say this person is in front. But if I move to the back here, you are going to hear the level reduce, but I haven't much changed the amplitude. So what I'm saying is, if this is the head here, it is going to block some frequencies, especially the high frequencies, in the fact that high frequencies have small wavelengths, so they are easily blocked by the head, the shape of the head and the ears. Unlike the low frequencies, which are going to meander behind the head because they have a long wavelength, which is usually sometimes longer than the size of the head. So they are going to reach this side, the front side, and someone is going to hear that this sound which I've heard is coming from the back because of the tone color of that sound. It's going to lack some high frequencies, but it's going to be more in low frequencies, telling that person that this dark sound is coming from the behind. And from there, the head also, as it blocks some frequencies, it also helps us to identify where the sound is coming from. Because if I speak here and the sound reaches the left ear, it's going to block those high frequencies, and the low frequencies are going to meander to the other ear, and that is also going to shape the sound such that the time the sound reaches our left ear, it would be lacking those high frequencies and be more in low frequencies. Therefore, the sound is going to be a bit dark. And what I should mention is the interoral level difference is the one which is usually used for high frequency, mid high frequencies, and this is because um, if I'm standing here and sound is blocked here, the level at which the high frequencies are going to be to reach the other ear are going to be less. Therefore, the interoral level difference is usually used to localize high frequencies. And to be specific, frequencies which are very high are hard to localize. Let's say above 10 kilohertz, you can't easily localize those sounds. The head-related transfer effect is going to determine where the sound is coming from, in the sense that it's not using the ILD or the it's not happening because of the comparison between the two ear. It's using the monaural cue, which is the effect of only what is happening on this side. So there is no comparison when it comes to very higher frequencies. So that is it. When we come to the low frequencies are usually localized by interoral time difference, simply because the low frequencies have a much longer wavelength. So if we say we want to localize low frequencies using the interoral level difference, we are going to find that the the wavelength of the low frequencies are going to meander behind our head, and what we are going to hear is a sound which can't be localized to say it's coming from this area or this direction. or the distance between us and it will be difficult. So the mid low frequencies are the ones which we localize using the interaural time difference, because even if the low frequencies are going to meander behind our head, we are going to use the interaural time difference to localize mid-low frequencies due to the fact that there will be a difference in the arrival time between the ears. Because if I speak here, it's going to reach faster here. And if I speak from your right here, it's going to be reaching faster this right here. And so we can determine to say we use these oral cues and our ability to store memory in audio. These abilities are used to recreate what is known as the stereo image. So the creation of this stereo image is out of understanding how the human head and the ears and everything, the nasal cavity, how it affects the sound. So these mics are sometimes known as equalizers, simply because even the way you use a microphone is going to determine the type of sound which is going to be reproduced. And again, you will find that these stereo images, they recreate the real atmosphere. So it is used to recreate that sensation of realism in audio. So they are very important in our studio engineering journey, and I would encourage everyone who is pursuing audio to at least have an understanding of what our perception of sound matters to the creation of this masterpiece of a technique. Thank you very much.